Thank you, Elliot. Hey everyone, I want to show you some of the enhancements we made to transactions in 4.2 in action. So we're going to talk about distributed transactions, large transactions, and changing a document's shard key. I have this cluster on Atlas. It has one shard in North America and one shard near Australia. And throughout the demo, I'm going to be using an example of an Instagram-like application. So I have a collection where every document has a user, who that user is following, and who's following them. The collection is sharded on the location field so that each user's document is located on the shard closest to where they live. I don't know if any of you recognized that walk-on music. That was Taylor Swift's new single that she just released a video for yesterday. So let's take a look at Taylor Swift's document. She has a lot of followers. She actually has 118 million Instagram followers, I checked. But I'm using a smaller data set so I can show you the shell output. But more to our interest, her document is located in the US. And you might know her friend, Lord, who's a New Zealander. So her document is located on the shard closer to Australia. And maybe Taylor Swift wants to start following her friend Lord. So we can model this with two updates, one to Taylor Swift's document to add Lord to her following array, and one to Lord's document to add Taylor Swift as a follower. We could run these updates one at a time, but wrapping them in a transaction gives us some extra guarantees. Specifically, either both of the updates will be applied or neither, and the updates will become visible in the same snapshot, so at the same time. And these are ACID transaction guarantees. OK, so we can run this. And as you might expect, now Taylor Swift is following Lord. But let me show you a little more about how we achieve these guarantees, even though these documents are separated by an unreliable network. As Elliot mentioned, one of the shards involved in the transaction will coordinate a two-phase commit. So in this case, I've connected to the shard that coordinated the commit for this transaction. And we can take a look at its op log. OK, so we see that first, the coordinator shard wrote down which shards participated in the transaction. It wrote down the updates that it itself had to apply with this, sorry, I'm scrolling too far, with this prepared true flag, which means it had acquired all of the locks and was ready to commit, but hadn't made the writes visible yet. And it told the other shard to do the same, write down your operations with a prepare flag. When it heard back OK, it wrote down the decision to commit and the timestamp at which the writes should become visible, and sent that info to the other shard. So I think that having the server handle this two-phase commit so that your data remains consistent, even if it's separated by a network, is a pretty powerful tool for developers working with distributed data. OK, so that was a distributed transaction. Now let's talk about large transactions. Say Taylor Swift decides to quit Instagram. So we can model this by removing Taylor Swift's document and removing her name from everybody who is following her and everyone who she's following. I might have gotten those backwards. The thing is, Taylor Swift has so many followers that this might result in more update operations than could fit in a single oplog entry. But that's OK, because in 4.2, we actually write the operations across multiple oplog entries and link the entries together in a chain. And when the transaction commits, all of the operations in the chain become visible together. So let me show you what that looks like. OK, this is one of the shards again. OK, so here you see the updates are spanning multiple oplog entries. And each oplog entry has a timestamp, as well as this prev op time field, which is a pointer to the previous entry in the chain. OK, so that's pretty cool. We can do transactions with an arbitrarily large number of operations. Finally, I want to talk about changing the value of a document's shard key. So this is not changing which field is the shard key, but just changing the value of that field in some document. OK, assume we have some user, Jane, who lives in Australia, and we're trying to load her data here in the US. So it takes a little while, 240 milliseconds. But what if Jane moves to the US? Well, we would want her data to move to be closer to her. Now we can do that by changing the location field. And notice that it uses the regular update syntax. There's no special syntax for changing a shard key. And underneath the hood, this is going to run a distributed transaction to delete her data from the Australia shard and insert it into the North America shard. And if we find her, if we try to load her data now in the US, we see it takes 10 milliseconds rather than 240. I hope you will find this trio of transaction features useful, and enjoy the rest of your day. Back to you.